Okay, so this next problem, we are given that OT is 5, XT is 12, and OX is 13. So let's label those parts. OT is 5, XT or TX is 12, and then this is 13 from O to X. So we want to verify what kind of triangle this is, basically. And if you don't remember any of your Pythagorean triples, then just use Pythagorean theorem. So our legs, 5 squared and 12 squared, and our hypotenuse, 13 squared, or the longest side. Might not be a hypotenuse. So now, 5 squared is 25, 12 squared is 144, and 13 squared is 169. 25 plus 144 is 169. Since this is equal to the other side, this means we do have a right triangle. Since we have a right triangle, since OT is perpendicular to XY, XY is tangent. So now we have another theorem to take a look at. The bisecting chords theorems. Now, one is just the reverse of the other, basically. So if a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. So that means that AB is a diameter, and since it is perpendicular to the chord XY, that means it cuts XY in half, both chord XY and arc XY. So that means that XZ is equal to ZY and XB is equal to BY, or congruent, depending on how you're looking to name them. The next part says that the perpendicular bisector of a chord is a diameter of the circle, which just goes the other way. So if we know that the perpendicular bisector of the chord is given to us here, so XY is perpendicular to AB and it is cutting XY in half, that means that AB is the diameter. Now that also can apply to radii, so it doesn't have to just be diameters. So if you're given a radius, use that same principle that we just saw here. Now try this next problem.